Welcome to another deep dive from Peaceful Rooster Experience. Today we're going to be exploring how Apache Spark tackles massive data sets,
Right.
making the process smoother and faster.
Yeah.
You can think of Spark as this super powerful engine
Mhm.
for crunching huge amounts of data.
Right.
But even with all that power,
Yeah.
it needs a little help sometimes.
Yeah.
Especially when we're talking about data sets that are, well, massive.
It's true. Even with the incredible processing power available these days, efficiency is still key.
Right?
And that's where partitioning and bucketing really come into play.
Okay, so tell me, how do these techniques, partitioning and bucketing, help Spark manage these mountains of data?
They're all about organization. Imagine a library with millions of books, but no system for categorizing or shelving them. It would be chaos.
Yeah.
Partitioning is like dividing that library into different sections, maybe by genre or author.
Okay.
Each section represents a partition, a manageable chunk of data that can be processed independently.
So instead of one librarian trying to handle the entire library,
Okay.
we have a team,
Right.
each responsible for a specific section.
Exactly. This brings us to the first major benefit, parallelism. Spark can distribute these partitions across a cluster of computers, allowing them to work on the data simultaneously. This significantly speeds up processing time, as multiple machines are tackling the workload in parallel.
That makes sense. Instead of a single chef trying to cook a feast,
Right.
you have a whole kitchen staff, each handling different parts of the meal. It's much more efficient.
Yeah.
But what about moving all that data around?
Yeah.
Doesn't that create a bottleneck?
That's where partitioning really shines. By grouping related data within the same partition,
Okay.
you minimize the need to shuffle data across the cluster. For example, if you're analyzing sales data by region, you could partition the data set based on the region column. This way, all data related to a specific region would reside within the same partition, reducing the need to move data around during processing.
So it's like sorting your laundry before washing. You wouldn't throw everything in together, right?
Exactly.
You separate colors, delicates, and so on.
Yeah,
This makes the entire process smoother and more efficient.
that's a great analogy. And this optimized organization also benefits common operations, like joins and aggregations.
Okay.
When data that needs to be analyzed together is already located within the same partition, these operations become significantly faster.
Now, I know our source material had a few code examples
Mm-hmm.
showing how partitioning is actually implemented.
Right?
One was for RDDs and the other for data frames. What stood out to you about those examples?
What's interesting is how simple and intuitive the implementation is. In both cases, you're essentially defining a key, and Spark uses that key to determine how the data is divided into partitions. You're telling Spark, hey, split this data up based on this particular column.
So it seems pretty straightforward, but are there any situations where partitioning might not be the best approach?
There are a couple of scenarios where the overhead of partitioning might outweigh the benefits. For instance, if you're dealing with a very small data set, the additional processing required to partition the data might actually slow things down.
So it's like using a bulldozer to plant a single flower. You might end up doing more harm than good.
Exactly. Another situation is when the keys used for partitioning are highly dynamic or unpredictable. If the values in the column you're using to partition the data are constantly changing, the effectiveness of partitioning diminishes significantly.
Okay.
Imagine trying to organize a library where the books keep changing genre.
Okay, so partitioning is a powerful tool, but like any tool, it needs to be used strategically. Now let's move on to bucketing. How does bucketing build upon this idea of organizing data within Spark?
Bucketing takes the organization a step further. While partitioning divides the library into sections, bucketing is like adding shelves within each section to arrange the books in a specific way.
So it's like creating mini categories
Yeah,
within each partition.
precisely. Bucketing organizes data within partitions
Okay.
based on a hash of specific columns. This ensures that records with similar values in those columns are grouped together
Well,
within the same bucket. Imagine arranging books on a shelf by genre. It makes finding specific types of books much easier.
that makes sense. But why is this so beneficial in the world of big data and Spark?
Let's say you're frequently joining two data sets based on a specific column,
Okay.
like customer ID. If both data sets are pre-bucketed on that column, Spark can perform the join incredibly efficiently. It's like knowing exactly which shelf in the library to go to find the book you need.
So instead of having to search through the entire library,
Yeah.
Spark knows exactly where to find the matching records,
Right.
eliminating a lot of unnecessary processing.
Exactly. And this optimized organization not only benefits joins, but also aggregations, especially when you're grouping data based on the bucketed column. Because similar records are grouped together, Spark can perform these aggregations much faster.
The source material had some examples showing how bucketing works, both for RDDs and data frames.
Right?
What stood out to you about those examples?
The examples highlighted how straightforward it is to implement bucketing in Spark. You specify the columns you want to bucket on, and Spark takes care of the rest, distributing the data into buckets within each partition based on the hash values of those columns.
So it's like setting up the shelves in your library, and Spark automatically places the books in the right spot based on their genre.
That's a great way to think about it. But it's important to note that bucketing, like partitioning, has its nuances. There are situations where it might not be the most effective approach.
That's interesting. When wouldn't you want to use bucketing?
One scenario is when you have heavily skewed data, meaning certain values occur much more frequently than others.
Okay.
If you bucket on a column with skewed data, you might end up with some buckets being much larger than others.
So some shelves in the library would be overflowing with books, while others remain mostly empty. That wouldn't be very efficient.
Exactly. This can actually lead to performance issues, as some Spark executors might be overloaded with work while others sit idle.
So what could be done to address this issue of skewed data when bucketing?
There are a few techniques to mitigate data skew. One is called salting, where you add a random value to the bucket key, distributing the data more evenly across buckets. Another approach is to choose a different bucket key that doesn't exhibit such a high degree of skew.
It's like coming up with a more balanced system for categorizing the books.
Yeah,
To ensure a more even distribution across the shelves.
precisely. Another situation where bucketing might not be ideal is when you have a data schema that changes frequently, or if you need to modify the number of buckets often. Rebucketing the data can be a time-consuming process.
So bucketing is best suited for situations where the data structure is relatively stable and the distribution of values is fairly even. It's about finding the right balance between organization and flexibility.
Exactly. And we've talked about partitioning and bucketing separately, but what's really interesting is how these two techniques can work together to create an even more powerful optimization strategy.
I was hoping you'd say that. It seems like these two techniques would complement each other perfectly.
Mm-hmm.
So how do partitioning and bucketing work together in harmony?
Think of it this way. Partitioning divides the library into separate rooms, perhaps fiction and nonfiction, while bucketing arranges the books within each room by genre. This two-level organization makes it incredibly efficient to find any book you need.
So it's like having the best of both worlds. The broad categorization of partitioning combined with the fine-grained organization of bucketing.
Exactly. The source material provided an example of combining these two techniques, demonstrating how they can work together to optimize data processing in Spark. It showed how you can first partition the data based on a high-level category, and then further bucket the data within each partition based on a more specific attribute.
I can see how this combined approach would be incredibly powerful in real-world scenarios. It's like having a super organized library where you can pinpoint exactly what you need in seconds. But I'm curious, what if the standard partitioning and bucketing strategies aren't sufficient for a specific use case? Is there any way to customize these techniques to meet unique requirements?
That's where custom partitioning and bucketing come in. Sometimes the default approaches just won't cut it.
Yeah.
You might have a unique data structure or a very specific way you need to process the data.
So it's like realizing that the standard library organization system doesn't quite work for your collection of rare manuscripts.
Right.
You need a more specialized approach.
Exactly. Custom partitioning allows you to define your own logic for how the data should be divided. Instead of relying on a simple hash function or a single column, you can write custom code that takes into account multiple factors, specific patterns in the data, or even external variables.
That sounds incredibly powerful, but also a bit complex. Do you have any examples from the source material that illustrate how this custom partitioning works in practice?
The source had a few Python code snippets that showcase this concept. One example demonstrated how to create a custom partitioner that distributes data based on the first letter of a string column.
Okay.
This could be useful if you want to process words starting with the same letter together.
So instead of just dividing the dictionary alphabetically, you're grouping words based on their initial letter.
Right.
This could be really helpful for tasks like analyzing word frequency or building a specialized index.
Precisely. The source also showed how to implement custom bucketing functions, giving you fine-grained control over how data is grouped within partitions. This could be beneficial if you need to cluster data based on a complex algorithm or a combination of different attributes.
It's like being able to define your own unique cataloging system for the library, tailored perfectly to your specific research needs.
That's a great analogy. Custom partitioning and bucketing provide that extra level of flexibility and control, allowing you to optimize Spark for very specific data processing requirements.
This has been a fascinating deep dive. We've covered a lot of ground, from the basics of partitioning and bucketing to their advanced applications and even custom implementations. What would you say are the key takeaways for our listeners?
The most important takeaway is that partitioning and bucketing are essential techniques for optimizing big data processing in Apache Spark. They help to organize data efficiently, reduce data shuffling, and enable parallelism, leading to significant performance gains.
It's not just about throwing more computing power at the problem. It's about working smarter, not harder.
Exactly. Understanding when and how to apply these techniques, as well as recognizing their limitations, is crucial for any data engineer or anyone working with large data sets in Spark.
I completely agree. This deep dive has definitely equipped me with a better understanding of how to tackle those massive data sets more effectively.
And remember, these concepts extend beyond Spark. Partitioning and bucketing, in their various forms, are fundamental principles in data engineering and can be applied to a wide range of data systems and tools.
So the knowledge gained here can be applied to other areas of data processing, making it even more valuable.
Right.
Any final thoughts you'd like to leave our listeners with?
As you continue to explore the world of data, always keep in mind that efficient processing is about more than just speed. It's about understanding the nature of your data, choosing the right tools and techniques, and constantly seeking ways to optimize and refine your approach.
It's like being a detective, constantly searching for clues and piecing together the puzzle to unlock the insights hidden within the data. Well said. Thanks for joining us on this deep dive into the world of partitioning and bucketing in Apache Spark. We hope you found it insightful and helpful. Until next time, keep exploring, keep learning, and keep sparking those data insights. Data insights, data insights. Data insights, 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 data insights.